When I started working with the BME 688 sensor, I didn't know what I would discover. I knew I would see something, but I didn't know what it would teach me. I am a PhD chemist by training. I've spent almost 10 years working with measurements, data, and instruments, mostly in labs. And even though I know the home environment is unpredictable, I'm constantly drawn to it because that's where we actually live. After making hundreds of coding tutorials, it felt like time to do something different. Not just software, not just hardware, measurement science with data science to understand the world we live in a little bit better. So today, I'm cleaning this bathroom. Now, it's somewhat small, and importantly, the ventilation is really poor. So before doing anything, I just want to see what the baseline looks like when I look at the VOC, the temperature, and the humidity. Before cleaning, everything looks good, it looks calm, and this is the part most people expect. Nothing happening, no drama in the data. I expected the air quality to change when I started cleaning. What surprised me wasn't that it changed, it was how long it took to settle back. Even after I finished cleaning, the signal stayed elevated for quite some time. Not minutes, but significantly longer than that. And that's where the story gets interesting. I'm not showing numbers here on purpose because it's not really about the specific sensor or a specific model. It's about a behavior. Air doesn't reset when we're done with an activity. It moves, it mixes, it lingers. And homes, especially older ones, have a memory almost. So this is why I'm interested in real environments. They don't behave the way you expect, and that's why it really matters. So in the next video, I want to show you what happens when I put a sensor on a vacuum. That one I really didn't expect.